Okay, for geometric proof number 4, we dispense with the same beginning of creating a given blue circle and roll it across a line to give us a given line for the top of the square. We don't need to do that. We only need to, we're trying to get to Kepler's golden ratio right triangle, the orange triangle. So we'll just start with a given 2-unit sided square. YHWT is 1, 2 units, okay? Then we chop the 2-unit square, whose perimeter is 8, into 4 equal white squares within the big white square, YHWT. And the next step that we do is the same as before in proofs 1 and 2, in which we want to create a rectangle, FBJA. So we just extend this 1-unit square to equal this 1-unit square, and we end up with a 1, 2, square root of 5, because we draw the diagonal AB right triangle. 1, 2, square root of 5, the number 5. Finding the midpoint of the diagonal at M, that's the midpoint, because that's the midpoint of the side too. We draw a 1-unit circle, this circle here, center at M, and where that circle intersects the rectangle's diagonal at C, AC is phi, the golden ratio, and C to B is the reciprocal of the golden ratio. So then we can take the radius AC, move it up to E, just rotate it up to E, and we have created a 1 square root of phi, phi, Kepler's golden ratio right triangle. We can go ahead and draw this phi radius circle. It's the red circle, okay? That's the circle, and the radius was phi, so the diameter of the red circle is 2 phi. We know the circumference is going to be pi times 2 phi. So let's look at the first, the white square, and expand the side, this distance here, to equal the square root of phi, the same as Kepler's side here. So this yellow square, KNP, R, has a side of 2 times the square root of phi. And we have 4 sides, so 4 times 2 is 8, times the square root of phi is the perimeter of the yellow square, the big yellow square. And that, that number will be, when you multiply it out, 10.176157119, out to 9 decimal places. That is the perimeter of the square. Using the value of pi that we have already discovered is 3.144605511, we multiply 2 phi times that pi, and lo and behold, we get the circumference of the circle equal to 10.176157119, which is exactly the perimeter of the square. So the perimeter of the red circle, whose diameter is 2 phi, is equal to the perimeter of KNPR, the square, whose sides are 2 times the square root of the golden ratio. What this really tells us is that all circles in the universe have a square, whatever it may be, and that the commonality is if you equate the circumference to the perimeter of a square, you can then discover that pi equals 4 over the square root of the golden ratio. We can see that you could do the same thing with a small triangle here. Just do it right here. We'll get to that in proof number 6 and show you some special attributes of the sides Kepler's golden ratio right triangle.